Welcome to Topic List Comprehensions. This is one of Python's powerful and elegant features. A list comprehension provides a concise, single-line way to create a new list based on the values of an existing sequence, often replacing multi-line for loops and append operations. 1. The traditional way. Imagine we want to create a list of squares for numbers from 0 to 4. Using the traditional method, we would first initialize an empty list, then use a for loop to iterate through the range, calculate the square, and finally, use the append method to add the result to the list. This takes 3 lines of code. 2. The list comprehension syntax. A list comprehension achieves the exact same result in a single line. The syntax is expression followed by for item in iterable. It is enclosed in square brackets, just like a list literal. In our example, x times x is the expression, and for x in range 5 is the loop. The result is a new list of squares. This is much more readable and faster to type. 3. Structure of a list comprehension. The structure is key. First, the expression, which is the value you want to place in the new list, such as x times x. Second, the loop, which defines what you are iterating over, such as for item in iterable. You read it in the order the computer executes it. For x in range 5, calculate x times x. To summarize, list comprehensions reduce boilerplate code and make your Python more efficient. Our next lecture 15.02. Cube of numbers in a list. See you there. Welcome back. In this lecture, we will practice our new list comprehension syntax by creating a list containing the cube of every number from an initial list. This is a list transformation task. 1. The traditional for loop method. To cube the numbers in our numbers list, we follow the long method. Initialize an empty list, loop through the source list, calculate number raised to the power of 3, and append the result. This requires 3 distinct lines for the operation itself. 2. Using list comprehension. Now, let's use a list comprehension. We write cubes_lc equals and open the square brackets. The structure is number raised to the power of 3, which is the expression, followed by the loop structure, for number in numbers. This single, compact line handles the initialization, iteration, calculation, and appending all at once. 3. The expression flexibility. Note that the expression part of the list comprehension can contain any valid operation, whether it's cubing, multiplying, calling a function, or formatting a string. As long as it returns a value, that value will be placed into the new list. To summarize, the list comprehension syntax is ideal for transforming every item in an iterable. Our next lecture 15.03. Even numbers in a list. See you there. Welcome back. We've used list comprehensions to transform lists. Now, let's unlock their more power by adding a conditional filter. This allows us to both iterate over a list and select only the elements that meet a specific criteria. We'll start by finding all the even numbers in a sequence. 1. The traditional filtering method. To filter out the even numbers using a for loop, we again start with an empty list. Inside the loop, we check the condition, if the number modulo 2 equals 0. Only if this if statement is true do we append the number to the new list. This requires 4 lines of boilerplate code to achieve simple filtering. 2. Filtering with list comprehension. The list comprehension is much more direct. The syntax for filtering places the if condition at the end after the for loop statement. It reads, for every number in numbers, include number, only if number modulo 2 equals 0. The expression part, number, is only evaluated and included if the trailing if condition is met. This is concise. 3. Structure with filter. The general structure now includes the optional if condition at the very end. The process is always iterate through the iterable, check the condition, and if true, apply the expression and add it to the new list. You may combine this with the transformation technique from the previous lecture, where the expression could be number times 2 instead of just number. To summarize, we've now seen how list comprehensions can handle both transformation and filtering. Our next lecture 15.04. Product of numbers in a list. See you there. Welcome back. We've used list comprehensions for transformation, like cubing numbers, and for filtering, like selecting even numbers. Now, let's combine these two techniques in a single, powerful line of code. We will create a list containing the product of numbers, but only for the numbers that meet a specific condition. 1. The combined operation using a for loop. To perform both steps traditionally, we iterate through the data list. We first check the if condition. If x is greater than 5. Only if that condition is true do we then apply the transformation, which is x times 10, and append it. This still requires 5 lines of code to achieve a simple two-step operation. 2. Combining transformation and filtering. Using a list comprehension, we achieve the same result in a single line. The transformation, x times 10, is the expression at the beginning. The filtering condition, if x is greater than 5, is placed at the very end. The process is sequential. It iterates, filters, and then transforms. This demonstrates how readable and efficient list comprehensions are for common data processing pipelines. 3. Filter then transform logic. It is important to remember the order when the if condition is placed at the end. The condition acts as a filter on the iteration. Only items that pass the filter are sent forward to be transformed by the expression. The expression is not evaluated for items that fail the filter. To summarize, combining transformation and filtering in a single list comprehension is highly Pythonic and efficient. Our next lecture 15.05. Common elements in a list. See you there. Welcome to our final lesson on list comprehensions. We'll tackle a slightly more complex scenario, finding the common elements between two different lists. We can achieve this elegantly by combining an if condition with a nested loop structure inside a single list comprehension. 1. The traditional nested loop method. Traditionally, to find common items, you would use a nested for loop. The outer loop iterates through list A, the inner loop iterates through list B. You then check if x equals y, and if true, append the common element. This results in a multi-line, potentially slow, block of code. 2. Using list comprehension. In a list comprehension, the nested loops are placed one after the other, in the same order they would appear in traditional code. The expression is x. The loops are for x in list A and for y in list B. The condition if x equals y checks for equality. This single line clearly and concisely expresses the intent to find common elements. Note that the output is still a list containing the common elements 3 and 4. 3. More Pythonic alternative. Although the list comprehension works, an efficient and Pythonic way to find common elements may be to convert the list to sets and use the intersection operator, the ampersand sign. We convert the result back to a list only if required. Set operations may be optimized for finding commonalities and may be much faster than nested loops. To summarize, we have learned list comprehensions, learning how to transform, filter, and even nest loops within this concise syntax. This concludes section 15. Our next lecture 16:01. Introduction. See you there.